As you can see in problems 11 through 20, the graph of the function f is given, and as we talked about in class, the first thing we're trying to look for here are the intervals in which f is increasing and decreasing. So we related increasing to green and the color green, and decreasing to the color red. So we have red, like kind of like red light, green light. And as if we read the graph from left to right, we can see that as we travel from negative infinity all the way to that point right there, where x is equal to -8, the y values are getting lower. And as we travel from -8 all the way to -2, it's hard to see that, but that's the green. And then as we continue on, we see from -2 to 0, the y values are getting lower, so we use red. From 0 to 2, the y values are getting higher. And then from 2 to 5, the y values are getting lower. And from 5 to infinity, the y values are getting bigger. So we use the colors, red and green, to represent the x values in which the y values are getting either higher or lower. So the first question here in the LT, problem number 12, is f decreasing on the interval from -8 to -4, and we see we have green, meaning the y values are getting bigger. So the answer to that question is no. For number 14, is f decreasing on the interval from 2 to 5? Well, from 2 to 5 we have red because the y values are getting lower on the interval from 2 to 5. So we would say yes. The function f is decreasing when the y values are getting lower. For number 16, the intervals in which f is decreasing. Well, everywhere we see red, we know that the y values are getting lower, so we would say from negative infinity all the way to -8, combined with the interval from -2 to 0, and then as well from 2 to 5. So that's the answer for number 16. So then number 18, is there a local maximum value at x equals 5? So the at would be the x. Is there a local maximum there? Well, when x is equal to 5, we could see the y value is 0, and it happens to be the lowest value of all the ones in the vicinity or in the small neighborhood around it. So no, there is no local maximum. That would be a local minimum. Okay, and then number 20, list the numbers at which f has a local minimum. Well, when we go from red to green, that means we go from decreasing, f is decreasing to increasing. We have a minimum right there. Anywhere from red to green, so we have red to green. So decreasing to increasing, there's a local minimum right there as well. And then we have another one right here, local minimum. So it's the low points. The low points on the graph are where we're going to have a local minimum. And what are the local minimum values? Well, the value would be the value of the function at that point. So the first local minimum at -8 is -4. The next local minimum at x equals 0 is 0. The minimum value of the function is the y value. And then we also have another local minimum of 0 at x equals 5. So I guess we don't need to really list 0 again. So we have local minimums of -4 and 0, and they happen at x equals -8, x equals 0, and x equals 5. So we can just put a box around that. Those are the two local minimum values. That's it.